Okay, we're up to video series number 5. Okay, this one's still alkanes, but now we're on to complex branches. So what does a complex branch involve? It's really a branch within a branch. Right, so what happens if we draw branches, and then we draw branches coming off of those branches? Okay. So let's put in an example. Here I have a pentane, and I'm going to put in, again, a different color, one branch. Okay, let's put it off to 3, like that. And this branch has 2 carbons. And then what happens if I put another branch coming off of that branch? Now I have a branch within a branch. Right, so my red branch has 1 carbon coming off of a green branch with 2 carbons, which is coming off of my main chain with 5 carbons. Okay. So we have to figure out how are we going to name this branch within a branch. So what we do is we use the same methodology. We're going to identify the longest chain in the branch, right? So in this case, whether we follow it along the green chain, we get 2 carbons on that branch, or if we were to follow it the other way, it would still be 1, 2 carbons going the other way. So the longest chain in the branch is 2 carbons. And then, so we're going to name that ethyl. We're going to do it in green, so we know which name goes with which branch. So this is ethyl. And then we're going to name the branch that's coming off of the main branch. And that's a 1 carbon branch, so we're going to call it methyl. Okay. And our numbering system for our main branch always starts with the number 1 carbon attached to the main chain. So this is going to be the 1 carbon of ethyl and the 2 carbon of ethyl. So since our methyl branch is coming off of the first carbon, we'll call it 1 methyl ethyl. And then what we do is we want to make sure that we're not confusing that this methyl branch is separate from this ethyl branch, and it might be in different parts of the main chain, like an ethyl branch here and a methyl branch there. Right? We don't want to make that confusion. So what we're going to do is we're just going to put the whole complex branch, right, in brackets to say that it's all part of 1 branch on just 1 carbon in the main chain, the 3rd carbon, right? So we can think of putting this whole complex branch in brackets. Right? So now we've named the branch. It's a 1 methyl ethyl branch. Okay? So then all we have to do is say, okay, what's our main chain? Well, again, this is a pentane, right? And of course, we need to make sure that we say where our complex branch is occurring. In this case, it's on the 3rd carbon of pentane. So we say 3, 1 methyl ethyl pentane. Okay. So that's how we name complex branches. Right? We put the entire complex branch in brackets, right? And we use the same methodology that we use with naming simple branches, right? Is that we find the longest chain first. In this case, it's an ethyl chain, right? That becomes the main part of our branch. And then we name any other branches coming off of it. So in this case, an ethyl branch coming off of the 1st carbon of the ethyl branch. And we put the entire complex in brackets and say where it is on the main chain. It's on the 3rd carbon. And of course, the main chain always goes at the very end. Right, so there are a few different examples of complex branches that we see commonly. So I'll draw another example. That was your 1 methyl ethyl branch. All right, so how about we do the 1, 2, 3, 4, 5, 6, 7. A 7 carbon long main chain. Here on the 4th carbon, I'll do methyl ethyl already. So we'll do 1, 2, 3, like that. And then I'll do a methyl branch coming off of that branch. Okay. So here's going to be our complex branch again in brackets. It's going to be this whole part. Okay. And since I've drawn it out colored, right, it's easy to see, somewhat easy to see that this is 1, 2, 3 carbons long, whereas if we went the other way, it would be 1, 2 carbons long. So we're looking for the longest part of the complex branch to be our main part. And so since 3 is longer than 1 and 2, right, this is going to be a propyl branch. Okay. And since the other red part of our branch is 1 carbon long, it's going to be a methyl propyl branch. And that methyl group is coming off of the 1 carbon. So it's 1 methyl propyl. And we're going to put that in brackets. And this is 7 carbons long, we're going to call it heptane. And this whole complex branch is coming off of the 4th carbon of heptane. So it's 4, bracket, 1 methyl propyl, heptane. Um, 1, 2, 3, 4, 5, 6. Yeah. Now, there is one issue that we have to consider when we're naming complex branches, and it arises with this, right? Is that sometimes when you're dealing with complex branches, you can find an equal length main chain, right? And that's what I was just counting out here. So we have 1, 2, 3, 4, 5, 6, 7 there. So that's a heptane. If we go 1, 2, 3, 4, we count up this way, 5, 6, so that's shorter, that couldn't be a main chain. If we count from this end, 1, 2, 3, 4, 5, 6, that's shorter, that can't be a main chain. If we count along this way, 1, 2, 3, 4, 5, 6, 7. If we count that way, from the end, we also obtain a 7 carbon long chain. So the question is, does it look the same? If I choose the same length for a carbon chain, but go on a different path. So let's remove the numbers. Let's see what things look like. We go this way. 1, 2, 3, 4, 5, 6, 7. So we also get a heptane when we follow it that way. Okay. Or vice versa, we started here, 1, 2, 3, 4, 5, 6, 7, which actually would make a lot more sense because here our first branch would be 1, 2, 3, 4 on the 4th carbon, whereas if we count the other way, 1, 2, 3, our first branch would be on the 3 carbon. So now that we've established that, let's number it the other way, make sure we're using the lowest numbers. 1, 2, 3, 4, 5, 6, 7. Okay. Now, we'll notice that this does, in fact, look different than if we named it the other way than we did before. So let's make that black for our main chain. Right now, we have this 1 carbon red chain sticking off of carbon 3. And rather than having a single complex branch, we're going to do this one in green. Right. We have another 1, 2, 3 carbon branch. Right, sticking off of carbon 4. So instead of having 1 complex branch, this being our complex branch, the way we named it before, right? If we number it this way, we have the same length main chain, and we have 2 simple branches. So potentially, right, we run into the issue of saying, okay, we'll still call this a heptane main chain, but rather than being 4 1-methyl propyl heptane, right, we could instead say, oh, well, this is methyl, this is propyl, M comes before P. So alphabetically, I'm going to put methyl first, and then propyl. So propyl will go there. It's 4 propyl. And then methyl, alphabetically first. And methyl, in red, here. And it's on carbon 3, so it'll be 3 methyl 4 propyl heptane. Right? Now, since I came up with both of these names, naming the same molecule, right? I'd say, oh, well, which one would be correct, right? They both follow the rule of using the longest chain, 7 carbons, right? So do I name it using a single complex branch on carbon 4, 1 methyl propyl, or do I name it using 2 simple branches, 1 on carbon 3 and 1 on carbon 4, 3 methyl 4 propyl? And the rule is that if you can name it using simple branches rather than complex branches, then you always choose the simple branch option. Right? So in this case, we don't have to worry about using a complex branch name, right? Because that name would actually be incorrect. This would be the correct name because we're using simple branches instead of complex branches. So you just have to check, do I have 2 main chain options that are the same longest length, right? And is one simple and the other complex, in which case you go with the simple option. So lastly, I'll just quickly go over a few other common complex branches. So here's one with 2 additional branches on our main branch. So we have 1, 2, 3, 4 versus 1, 2, 3, 4, 5, 6. It will be 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have a no name. We don't have any other options for longest. 1, 2, 3, 4, 5, 6, 7, 8. Anything else is going to be 8 or fewer. Right, so no name is how we're going to go. So we have to name this as a complex branch. So what are we going to call this complex branch? Well, the longest single branch coming off is the green one, 1, 2. If we follow any other path, 1, 2, 1, 2, we get 2 no matter what. And coming off of the longest branch there is a single carbon blue chain and a single carbon red chain. So what are we going to call this? Well, of course, the longest one being 2 carbons long, this will be an ethyl branch. And we have 2 methyl branches coming off of it. So we're going to call it a dimethyl ethyl branch. And of course, we have to say where they're coming off of, right? And they're both coming off of the first carbon in the ethyl branch. So we call it a 1, 1 dimethyl ethyl branch. And that, of course, all goes in brackets, being a single complex branch. Where is it? It's on the 4th carbon of the main chain. And our main chain is a no name. So this would be 4, 1, 1 dimethyl ethyl no name. So 1, 1 dimethyl ethyl is another complex branch that we might run into. I'm going to maintain the same structure for the next complex branch that we look at. So I can take out that from the brackets, take out that. Okay. So all that will stay the same. We're just going to put something new in here. So we did 1 methyl propyl, we did 1 methyl ethyl, we did 1, 1 dimethyl ethyl. So how about 1, 2, 3? one carbon branch on the second carbon here. So what do? Well, first we look for the longest branch. So it's 1, 2, 3. So this is going to be a propyl branch. And there's a methyl branch coming off of it at the second carbon. So it's going to be a methyl branch at the second carbon, 2-methyl propyl. Right, so this would be 4 bracket 2-methyl propyl, no name. Okay. So I think that covers most of the complex branches that you're likely to see. Only one more alkane lesson left to go.